Hello, this is Jack Jackson. In this video, we're going to talk a little bit about French mathematicians of the 18th century. We've been talking in this playlist about mathematics in the 18th century and talked a lot about the Bernoullis and Euler and others that are centered in Switzerland, Germany, Russia. And in general, Europe became the area of greatest mathematical advances really from the 16th to the 19th century. But there was no real single center of Europe for mathematics, such as the Library of Alexandria was for the ancient Greeks, or the House of Wisdom in Baghdad for medieval mathematics. Oxford, London, New Amsterdam, Basel, Berlin, Milan, Venice, St. Petersburg, and others had important learning centers, and France also had its collection of important mathematicians in the 18th century, building on the tradition there of Descartes, Fermat, Pascal, and others from the previous century. Paris in particular became a leading mathematical center. The University of Paris had become an early center of mathematics along with Oxford. It kind of lost its leading edge, but especially toward the end of the 18th century, there was a group of mathematicians in France that became pretty prominent. Now, this was a turbulent time politically. If you're in America, you know that 1776 is an important date. That's when the United States declared independence from Britain. And so the Revolutionary War was going on there in the 1770s. And in part, that helped lead to the French Revolution of 1789. And the France had a turbulent political period there for a while, going from a monarchy to the French Republic after the French Revolution, and then the rise of Napoleon, uh, who eventually became a dictator, and Napoleon's you know wars of conquest to try to take over Europe, and of his eventual demise, the return of the monarchy, and then eventually the French Republic again. That happened over a period of time, but a lot of this was happening right there at the end of the 18th century, and many of the mathematicians that we're going to be talking about here really got kind of tied up in uh, that conflict. And specifically, I'm going to talk about all about seven mathematicians here. De Lambert, who is kind of the elder statesman of the group, was born in 1717, died in 1783. And then Lagrange, Condorcet, Monge, Laplace, Legendre, and Carnot. These mathematicians, most of them, if you look, were born kind of in the mid part of the century and lived toward the end of the 18th century, or really even into the early parts of the 19th century. Collectively, these mathematicians were involved in several things. One of them that was very important was uh, after the French Revolution, one of the first things that the Republic did, actually before the Revolution, there was a committee put together to look at a system of weights and measures, and this committee was encouraged by the Republic uh, Republican government there in the early part of the after the French Revolution, and that led to our modern metric system. That alone is a very important thing. But there was continued advance of calculus, differential equations, calculus of variations, a lot of very important work in probability theory and geometry, advances in physics, astronomy, and in education. And we'll talk a little bit about each of these mathematicians individually here just a bit. So, D'Alembert, Jean-Laurent D'Alembert, was born in 1717, died in 1783, lived in France. His father was an artillery officer, and his mother was a socialite. Um, she apparently was originally a nun, got released from that vows, and ended up having a number of romantic liaisons with a number of people. One of them led to the illegitimate birth of Jean Laurent de Lambert. Uh, he was left at a church called Laurent, which is where he got that name, and taken to an orphanage. But not long after that, his father returned from war or wherever and military service, and made sure that Jean was raised uh, okay, and he was raised by Mademoiselle Rousseau, who he basically considered his mother. Um, his father and his father's family paid for his education. Mathematically, he's important for his work with integral calculus. He was worked with physics. He worked on a conservation of kinetic energy and mechanics. He helped work on an encyclopedia, writing a lot of the mathematics portion of that encyclopedia. Worked with differential equations, and he is really considered the pioneer of partial differential equations. He's the first one to really get that field up and going well. Lagrange, Joseph Louis Lagrange, was born in 1736 and died in 1813. He's actually Italian. Um, he was born and raised in Italy, but he's considered both Italian and French. He did have some French ancestry on one side. He liked to consider himself French, at least at some points. But his early work, his early life, his um, early training, which was actually mostly self-taught early on, happened in Italy. He went to school some in Turin and then taught at Turin for quite a while in Italy. He eventually then succeeded Euler when Euler left Berlin in 1766, and then um, for about 20 years or so, Lagrange was in Berlin. And then in 1787, he moved to the Academy of Sciences in Paris and stayed there until his death in 1813. So he was, Italy, Germany, and France. His family was from Italy. He was Italian by birth and by part of his heritage, but then French as well. So he's kind of considered French and Italian both, although he was in Germany for 20 years as well. You probably have heard of him in terms of Lagrange multipliers that we use for constrained optimization problems and multivariable functions. He also worked on calculus of variations, analysis, number theory. He did some work on massive vibrating string. Euler also solved this, but he used a completely different method than Euler, and he and Euler uh, were in conversations with each other with correspondence. He worked on astronomy, mechanics, celestial mechanics, dynamics, fluid mechanics, and his analytic mechanics uh, textbook summarized the mechanics since Newton and made it very more mathematical. So he did very much mathematical type of physics and mechanics there. And his book was a good summary of more recent results. He also did a lot of work in probability. He did some work on the foundations of calculus, trying to work on the theory behind calculus a little bit, kind of, foreshadowing a little bit of the work that was going to be done in the next century. He did some work on permutations, and that's seen as a first step towards group theory. Group theory wasn't really formed until the next century, but one of the most basic results in group theory is due to Lagrange. So some of the group theory goes back at least as far as Lagrange, and he was actually the chair of the committee on weights and measures that gave us the metric system. Condorcet was born in 1743 and died in 1794. By the way, I'm doing these kind of in increasing order of their birth, so oldest to youngest. He was a marquis, which means he was part of the aristocracy, but he didn't really consider himself, he was nobility, but he was actually very much in favor of the revolutionary ideas. He participated in the French Revolution. He ended up being the Paris representative and legislative assembly after the revolution, and he argued for the equality of men and women. And so he was very more egalitarian than even though he was from the nobility. He worked on probability, philosophy of mathematics, difference equations, differential equations, and economics. Gaspard Monge, born in 1746, died in 1818. He's another French mathematician. During the later part of life, he was also known as the Comte de Plus. Sometimes you might see him by that name. He was the son of a merchant, so he did not grow up as part of the aristocracy. But he excelled in school when he was young, and he started teaching very young. He actually taught a university course in physics at the age of 17. He ends up becoming a very important teacher. He lived in the city of Bonn, and he made a plan of his hometown city. He became kind of a city planner. He worked on the calculus of variations, infinitesimal geometry, partial differential equations, combinatorics, and he's most well known for his work in geometry. He is the father of differential geometry. He is very important for 3D geometry. He worked on lines of curvature of a surface in 3D space. He did orthographic projections. He's responsible for taking 3D objects and looking at them maybe from the front, the side, and the top, like we do with architectural plans now. That's a pretty common thing now, but he was revolutionary in doing that and studied surfaces. Politically, he supported the revolution. He briefly became a minister of the Navy in the New Republic. He was also on the Committee on Weights and Measures. And one of the things that the Republic did was they set up two schools. The École Normale, so the normal school, that was for training of secondary teachers. That was the lesser prestigious group of school of the two. And the École Polytechnique. So the Polytechnic school was the more advanced school, and he was the director of that. And he became a very, very influential teacher, and he was especially adept at teaching and at administrating and at doing research mathematics. So that's a kind of an unusual combination to see someone that's completely as adept and advanced in doing that, all three of those areas. And he was very important for establishing these schools, both the schools. He taught at both of them, as did some of these other mathematicians that we're mentioning. And so they had some top flight mathematics teachers at both of these schools, and it really helped establish uh, teaching from there on. Um, I will say that collectively, the textbooks written by this group and some people who were students of theirs became standards not only in Europe but in the United States of this time. So the early years of the actual United States, they were using these French textbooks quite a bit. He did support Napoleon. He was part of an expedition that went to Italy, which is where he met Napoleon and became a friend and supporter of his. And then he sort of followed Napoleon in his rise to power and joined Napoleon's expedition to Egypt. Next, let's talk about Pierre-Simon Laplace. Laplace was born in 1749 and died in 1827, so he is, late part of the 18th century on into the first part of the 19th century, and he studied some under the Lambert, and he eventually became the top mathematician in Paris at the Academy of Sciences. He collaborated and competed with Lagrange when Lagrange finally arrived there, and so those were two of the top mathematicians of that time period, of the last part of the 18th century, and they kind of helped spur each other on to greatness, you might say, at that point. Laplace was a little different than say the last couple of people we've talked about. The last couple of them were involved in the revolution and got heavily involved with it. Laplace, on the other hand, just tried his best to get along with whoever was in power. If it was the monarchy, he was cool with that. If it was the republic, he was cool with that too. He was okay with Napoleon. He just worked with whoever was there, and managed to sort of get through some of the turbulent times that way. You probably heard of him in terms of Laplace transforms and differential equations. He's also known for his Laplace coefficients, difference equations, work with potential function. He talked about the stability of the solar system, And one of the things that he did is he worked on mathematical probability. He was one of the most important contributors to the theory of probability, period, ever. And he worked with generating functions and approximations, worked on what's now called Bayes' rule. He did worked with compounded events, least squares regression, did some work on that, and inverse probability. And he wrote a textbook on probability that was important during that time as well. Legendre was born in 1752 and died in 1833, another French mathematician. He came from a wealthy family, and he won a prize early on for describing the motion of projectiles like cannonballs and such. He did a lot of work in mathematical physics, celestial mechanics. He's known for something called Legendre polynomials. He did work with elliptic curves and elliptical integrals. And he actually wrote a geometry textbook that became the leading geometry textbook for a century, his Elements of Geometry. And he tried to basically he took Euclid's Elements, updated it, tried to streamline it and make it more readable to what was his time, a modern audience. And he added some things to it. He proved that pi and pi square are irrational. Um, and he spent 30 years trying to prove the parallel postulate. But of course, not only was he wasn't able to do that, he wasn't able to realize that you can't do that and come up with hyperbolic geometry, something that came a little bit later. But he did lay the groundwork for some of the later work that was to be done there. He also worked a lot in the theory of numbers. He gave a bound for the function pi n, the number of primes less than or equal to n. And the bound that he gave there was pi of n is bounded by n divided by log of n minus 1.08366 time. Okay. There we go. Clean that slide up a little bit. He also worked on something called quadratic reciprocity and least squares regression. He actually did some least squares regression before Gauss and worked on quadratic reciprocity, but his proof was inferior to that of Gauss, who was a young man in the 18th century. And there was some conflict between Legendre and Gauss over this, but Gauss ultimately had the better proofs, and these two things are most often associated with Gauss. Next, and finally, let's talk about Carnot. He was born in 1753 and died in 1823, and it was another one French. He worked on the foundations of calculus and geometry. He was trying to put geometry on a universal setting and magnitudes used systematically. And so he's another one that became involved heavily in the revolution. So these mathematicians collectively worked through a lot of things. They really advanced the study of geometry, the writing of textbooks, the analytic geometry, three-dimensional geometry, um, and they were also involved in pushing calculus forward. So this group of mathematicians were really the most prominent ones in the last part of the 18th century, going into the first of the 19th century, and they were also very much right in the middle of an extremely turbulent time in an age of revolution there. And that kind of sets the stage for mathematics in the 19th century, which will be our next playlist.